If you have seen video 112, you know that there is one job left. We have a mainboard killed by overvoltage, and today we wanna go and fix it. Welcome to TRX Bench. Alright, and it has taken a while until I got all the parts, and now I have what we need, especially here are little buck converters to get our 3.3 volt parts back running. And of course we have here some little chokes and diodes and caps which has been burned off, and so everything is now available, and so we really can take the chance and try to fix it. I mean, of course there is still a risk, as overvoltage is really no fun, but on the other hand we really want to try it because that is what we are standing for, and beside that we need always a board to swap out for another unit, so nothing wrong with trying to get this running. Okay, and everything is prepared that we can swap out, or better said, that we can solder in our buck converter down here on the board. And yeah, let me show you something how we proceed. Okay, so this is the area where our buck converter sits normally, so that is a 3.3 volt buck converter to supply our MCU. And you see this here was our little choke which was burned out, so that was open. And yeah, we have taken the buck converter off in the first video when we recognized that it was dead short. And now our next job is to clean this area, because this is still lead-free solder which has been used. It is used in all the new electronic stuff, but for rework I personally prefer leaded solder, and therefore first of all we really have to clean it off, that we can use leaded solder. So let's do that first. Okay, so let's clean it. So I simply put here some new leaded solder down here to our PCB, just to clean it here a little bit, and to get here our first leaded solder down to the board. And of course we need it here as well. Okay, so when we have it down here to the board, then we will definitely clean it off. And therefore we take this here. Very nice. And you see, there is really a lot of ground plane behind it, and that means it is definitely not easy to get it all clean. And what you see as well, we have already lost one pad down there, but that is not a problem, because this pad is not used, so no problem at all. But you see how sensitive this all is, and therefore really it is critical to get it really done right. It is not easy. Okay, but now it starts looking good, so that I can go with the next step and clean it up with alcohol. Okay, but first of all, yeah, it is really a lot of ground, but first I will add some flux, just to get the rest of it away, and then we can really go and finally, okay, now we can once again clean it, and that is exactly what we need to prepare it here. And again, we can feel it is sticking here to ground, and that is, as I already said, it is really a lot of ground, and the new buck converter really needs to go down here to this ground plate, and therefore it is a not easy task. Okay, and it is cleaned so far, and now we have to fit in here our new buck converter. And you see we need to take care on the orientation. So you see here the little dot, and yeah, you can see it here and there, and also we can see it in our schematic that we need to rotate it until we have this dot here in the left upper position, like so, okay, and that is how we need to finally solder it in. But once again, if I flip it over here, you see this little packs here have a ground plane here under it, and that is yeah, the real challenge to get this really soldered back to our PCB, and that is what we need to take care on. And therefore first I have now to prepare here the board with some new solder, and then we have to put flux onto it, and then if the new chip is in, we have to replace this capacitor here, because you see it is not lined up here, and of course we need to replace here our new coil. And of course, just to give you the idea, these jobs can't be done without a hot air rework station like this or any other. So this is an Hacko, and But basically that is what you need, because otherwise you are definitely not able to do jobs like this. Okay, and what you can see is that now our pads are prepared for soldering. I'm still cleaning it the last time, and you see we have new solder on here on our solder points, and I already said that the ground plane here is really a huge heatsink, so it is really not easy to melt here the solder in the middle, and therefore it was as well important to have this solder points here, so the normal connections here a little bit higher. So the new solder what I have put on needs to be a little bit higher, that finally here our new part is sitting a bit higher, okay, and then we start melting it and see that it really gets here into this square. So you see here the markings around, and that is where finally our ship needs to sit. I mean, right when we start soldering, it is not so important, because due to the tension, the solder tension, it should be drawn into the right position. Yeah, let's see that we can manage it. And of course I apply here our flux, so that is a kind of sticky flux, and yeah, flux is the most important step we have to do, and after that we can definitely place here with the right orientation to our solder to the PCB at least, and then we can finally start soldering here our little pack. And I'm much too accurate for the moment in time, because it will jump around a little bit until the solder gets melting, and then it will hopefully pull into the right direction. Yeah, and as always we have to heat the board first, and that is what I'm doing, and what you already see is what I said. So here our chip is really moving here on the board, which is a kind of normal until it really starts melting. So that is really okay so far, no problem. And yeah, still really heating the board, that is important, otherwise you really can damage a lot. So therefore, let's see, we really need to be patient with jobs like this. But finally it will work. Now I go a bit deeper. Hope that the board is already warm enough. But our solder is not melted yet. So we heat it and see when it starts melting. Okay, so our new buck converter is in so far, and yeah, this here, this cap has corrected. It is now fine. Now we have here to add our little choke, which was burned out, and yeah, then we are more or less ready to go. Okay, so the choke is in, but I have to fit here a 10K resistor for the 3.3 volt buck converter, and that is a bit of a pain, as I do not have the right size. So I mean, this is already very tiny. It is a 0603 size, which is already really tiny, but as you can see, it is too big, so I have to fit it in here somehow. I mean, this all is ground, so I may get it somewhat like this here, that really finally our buck converter can work on 3.3 volt. Yeah, let me fit it in somehow here. Okay, and finally our 10K ohm resistor is in, and yeah, we are ready to go ahead. Now that is once again the situation how it looks like when you look with bare eyes here on the board. Can you find our 10K resistor? It is down there. So now I'm right on the top of this resistor, and you see even it is a 0603 size. You see it is too big, but on the other hand you can't really see it here. Okay, and of course I have here a unit where we can test it with. And yeah, I have already put the other components which we known that they were gone faulty. I have replaced them, and I did here a bridge where we know that somewhere here in the layer something got broken. So everything has been done. Here is our buck circuit underneath, so our little DC-DC converters. And yeah, now we are ready to test, and yeah, let's see if our radio will work again, because that is of course of anybody's interest. Okay, so let's simply see what's going on. Hey, yeah, have a look. That is excellent. So radio is working. Great. So let me check if it will receive, and if it will receive, then of course I can put here the shielding back to let me turn it down. So then of course I can put here my shielding back, yeah, of course from the other side, for the little DC-DC converters. So that is of course what I have to do. But yeah, let's see if the receiver is working. And but anyways, I mean the 3.3 volt is working, because otherwise the radio wouldn't start up, because the 3.3 volt is the supply voltage for our MCU, and without that little DC-DC converter it wouldn't work simply. Okay, so everything is prepared so far. Let's see, first of all, our speaker. Yeah, it is just fine, and now let me put it in. And great, isn't it great? Excellent. Let me see. Just fine. Simply fine, and it is working really good. And I'm running here okay, and I'm running here minus 100 dBd, so let me show it to you. Yeah, here you can see it, minus 100 dBm. An excellent, can you see it? Let me zoom it in. An excellent tone, and let me see how it feedbacks. And 1 kilohertz, it is really, yeah, here you can see it, it is really good in tolerance. And let me increase here a little bit our signal up to minus 73, and excellent. Look here, Synod is simply excellent, so I do not need to go any further. So what we really can say, it is back working, and yeah, that makes me really kind of happy, because now we have this board back and we can use it. I mean, yeah, it is used board, and there is finally a little bit, yeah, it could happen that there will be another fault which comes up due to the overvoltage, but we will leave it run for really a couple of days, and we'll see how it works. But anyways, first of all, now we put back here our shielding, and yeah, then it is really very close to what we really need. Okay, so, and that is what I meant. So we need to put it here over our buck converters or DC-DC converters, whatever you want to call it, and then I have to solder it back, and yeah, then it is really, we are really close to what we want to have. Yeah, and again we have a lot of ground here, and therefore it is, you really need the right temperature, and you need an iron with has enough power just to be able to melt the solder here with all the heatsink around, so I mean the ground plane. But you see here with my iron, and that is a micro pencil with 80 watts, and you see that is working really fine. So this micro pencil, by the way, that is a Weller, and it is really doing this job very nice, as you can see. And now, so everything is back as it should. Now I clean it here a little bit, and yeah, then we can go ahead. Okay, so, and that is really all I can show you so far. Well, the only thing what it is not so fancy is when we go here on the board and we have here our wire, our bridge. I mean, I will fix it here, of course, on the board, that it can't really move off. So that is what I will do. Well, that is not really fancy, but considering that the board is working and thus we can use it for another radio, is simply great. I have meanwhile tested if it is also transmitting, and that is a fact. So radio is definitely working completely. Everything is fine, transmit, receive, everything perfect, and therefore that's it. I mean, nothing else I can show you. Everything is fine, and I will stop the video here. I hope you enjoyed it a little bit. I was showing a little bit micro soldering today, so maybe that was a bit interesting how this can be managed. And yeah, therefore that's it for the day. Thanks for watching, and catch you next time. Bye.